Welcome, ladies and gentlemen. So what I'd like to do is show you how to evaluate the sum and difference formula using the tangent formula. And this one usually gets a lot of students when we go through this process because the tangent formula is much different than the sum and difference formulas for the sines and cosines. However, basically the process to getting it all set up is going to be exactly the same. So we should either have these two formulas or know them before we go ahead and take our test. But if we have our homework, we should have them either in our notes or definitely in our book to use. So the first thing we're going to want to do is obviously write down exactly what the sum and difference formulas are. And so here you can see that I have two angles. Now again, if you remember in my last video for sine and cosine, I did all different examples. I did ones where they're in degrees, one they're in radians, and then one where it's just one angle. So in this example, though, we have both of our angles separated. But if you have only one angle, remember you have to separate it either by addition or subtraction of angles that you're familiar with on the unit circle. For instance, 30 degrees, 45 degrees, or if it's in radians, like 4 pi over 3, pi over 4, pi over 6, pi halves, and so forth. All right, so let's go ahead and get into this. Let's go ahead and write down what the sum and difference formula is. So the sum formula for tangent of two angles here, we write down the tangent of x plus y is going to be equal to, put that up a little bit, the tangent of x plus the tangent of y divided by 1 minus tangent of x times tangent of y. Now, I don't remember these formulas off the top of my head, so I want to make sure that I go ahead and check them because I'm teaching in the summer right now. But once I start teaching and I go through these, I basically get these remembered pretty quickly. So especially if you have a test you're not going to be given to them, I'd really recommend making sure you do enough practice problems where you can reiterate all these angles quickly. So now what we notice is, again, we have two angles, x and y. So we need to find an x and a y angle. So again, just like we did for sine and cosine, I'm going to label my two angles, one x and one y. Then all we're simply going to do now is plug in, replace x with 30 degrees, replace y with 45 degrees. So that's going to look something like this. And I'm going to move it over just a little bit. So therefore, I have the tangent of 30 degrees plus the tangent of 45 degrees divided by 1 minus the tangent of 30 degrees times the tangent of 45 degrees. So now we need to go back and remember what the tangent of 30 and 45 degrees are. And that's not as simple as the sines and cosine. If you remember, the reason why we chose points that we know angles that cross the unit circle at a certain point is because we want to use those coordinates to help evaluate for sine, cosine, and tangent. Well, sine and cosine was pretty simple. We know that cosine represented the x coordinate of that point, sine represented the y coordinate, and then tangent, remember, is the y over the x. So I am going to quickly go back over the unit circle here real quick. Hopefully you have the unit circle kind of written out, so you can do this on your own, or you already know what tangent is. But I want to just be able to show it because I'm doing everything on my own. So remember, the first angle is pi over 6, or 30 degrees. The next angle is going to be pi over 4, or 45 degrees. And the last angle here is pi over 3, or 60 degrees. Then for each of these points here, I have square root of 3 over 2, comma, 1/2. Square root of 2 over 2, comma, square root of 2 over 2. And the last one is 1/2, comma, square root of 3 over 2. So if I want to evaluate for the tangent of 30 degrees, right, that means I need to take the y coordinate over the x coordinate. So I'll write this as tangent of 30 degrees is equal to 1/2 divided by the square root of 3 over 2. Now, hopefully this is something that you're familiar with and you remember. We can multiply by reciprocal. We could divide out the 2's here. Therefore, I'm left with 1 over the square root of 3. Then I have to rationalize the denominator. And I'm finally left with the square root of 3 over 3. So in here, so for the tangent of 30 degrees, that's going to equal to the square root of 3 divided by 3, plus the tangent of 45 degrees. I'm just going to write it out, even though it should be pretty obvious. Tangent of 45 degrees is the square root of 2 over 2 divided by the square root of 2 over 2. which hopefully you guys can see is just 1, right? They're exactly the same fraction. So that's going to be plus 1. And then that's all divided by 1 minus the tangent of 30 degrees is going to be the square root of 3 over 3 times 1. So now basically what we have is a complex fraction. And one of the things that we learned with simplifying complex fractions in Algebra 2 is to get rid of your denominators in your numerator and denominator. So what we have here is I have a 3 in my denominator. And here's the 1. So what I could do is if I multiply the top and the bottom by 3, then those 3's will divide out in the denominator. So that's exactly what I'm going to do. I'm going to multiply the top and the bottom by 3. And again, remember, as long as you add a fraction by the same number in the top and the bottom, you're not going to change the fraction. So, for instance, I always go through this, but students kind of always forget it. If I have the fraction 1/2 and I multiply by 3 over 3, I end up getting 3 over 6. Well, 3 over 6 is still equivalent to 1/2. So I haven't changed the value when you multiply the same number in the top and the bottom. OK. But it's important, since we have a binomial here, that I have to apply distributive property. OK. Now, I'm not going to show my work because I'm getting a little bit low on space. So 3 times square root of 3 over 3 is just going to leave us with the square root of 3. 3 times 1 is going to leave us with 3. 3 times 1 is 3. 3 times negative square root of 3 over 3. The 3's, again, are going to divide out. You can think of these 3's as over 1. So the 3's will divide out, leaving me with the square root of 3. So then some forms like to leave it in that format. That's a minus. OK. Some people are OK with leaving it in that format. But I kind of go over the pressure. As far as simplifying it, we got to get rid of our to simplify it, we got to get the radical out of the denominator. So what we learned about getting the radical out of the denominator is multiplying by the conjugate. 3 plus the square root of 3. And you multiply by the conjugate. And if you remember, we did conjugates with square roots as well as with imaginary numbers. We know wherever you have a binomial, you multiply by the exact same, but the opposite sign. Then, basically, now what I have to do is I apply FOIL up top. OK? So you go ahead and apply FOIL up top. And then the bottom, anytime you multiply a binomial by its conjugate, it's going to be like the difference of two squares. So that's going to end up giving me, let's see here, square root of 3 times, or let's do 3 times 3 is going to be 9. 3 times square root of 3 plus 3 times square root of 3 is going to be plus 6 square root of 3. And square root of 3 times square root of 3 is going to be the square root of 9. Plus 3 is going to be, or square root of 9, which is just going to be 3. And then the denominator, I have 3 times 3, which is 9. Minus the square root of 3 times the square root of 3 is going to be minus the square root of 9, which is minus 3. OK? Then what you can see is I can combine these terms here to give me 9 plus 3, or 9 plus 3 is going to be 12, plus 6 square root of 3. Actually, let's use a different color. Uh-oh, man, I'm taking a lot of space here. That's going to give me 12 plus 6 square root of 3 all over 6. And then my final answer, you see that 6 is a common term of my numerator and my denominator. So I can factor that out. And by factoring a 6 out, I'm left with 2 plus the square root of 3. And that would be my simplified valued answer. OK. So now let's go ahead and get into tangent. So now we're doing a difference, and we're using angles that are radians. However, the process is basically going to be the same. The first thing we want to do is write down our formula. So the tangent of x minus y is going to equal tangent of x minus tangent of y divided by 1 plus tangent of x times tangent of y. Hello. Please tell me. OK, cool. All right. Did that all right. So now we need to identify what our x and our y is. Again, so this will be x minus y, so it's x minus y. Now we just go ahead and plug in our values. So here I have tangent of, let's write this over here. So I have tangent of 4 pi over 3 minus the tangent of y. Now remember, y is not negative pi over 4. Y is pi over 4 because it's x minus y. So x minus y. That means y is pi over 4. So tangent of pi over 4, all divided by 1 plus tangent of 4 pi over 3 minus tangent, times tangent of pi over 4. OK, so in the first quadrant, we have pi over 4, right? Tangent of 45 degrees, which is the same thing as pi over 4, right? 45 degrees, tangent of pi over 4, exact same. However, 4 pi over 3, we do not have. So what we have to do is kind of continue this unit circle here. Well, if this is pi over 3, that would be 2 pi over 3. That would be 3 pi over 3. And 4 pi over 3 is going to end up being in the third quadrant. In the third quadrant, tangent is still going to be positive. So, but now we're dealing with the tangent of pi, the pi thirds, right? It's exact same points, except they're both negative. So let's just go ahead and do the tangent of pi over 3, because we didn't do that one yet. So if I did the tangent of 60 degrees, or pi over 3, that's going to be the square root of 3 over 2 divided by 1/2. Then by simplifying this out, I'm left with the square root of 3. OK, so if I change this to the third quadrant, that would be negative square root of 3 over 2 divided by negative 1/2, which would still give me the square root of 3. So therefore, basically, what I'm dealing with now is tangent of 4 pi over 3 is going to be the square root of 3 minus 1 divided by 1 plus 1 plus the square root of 3 times 1, which is just the square root of 3. Then what we can do is, just like we did before, we can multiply by the conjugate. Luckily, I don't need to multiply by 3 on both sides. I can just multiply by the conjugate here. 1 minus the square root of 3. 1 minus the square root of 3. And by doing that here, again, apply FOIL. So therefore, I have the square root of 3. Let's just write this one out. So I have the square root of 3. I hate when they're not written like that. So annoying. All right, so square root of 3. Square root of 3 minus square root of negative 3 is going to be minus the square root of 9, which is negative 3. Negative 1 times 1 is negative 1. And negative 1 times negative square root of 3 is going to be a positive square root of 3. Then in the denominator, I'm going to have a difference of 2 squares. So that's going to be 1 times square root of 3 times negative square root of 3, which is going to be a negative square root of 9, which is negative 3. OK, so therefore now this can simplify to negative 4 plus 2 square root of 3 divided by negative 2. Now I can divide that negative 2 into both of these terms, and I arrive at a final answer of positive 2 minus 1 square root of 3. Because that 2 is going to divide into both of those. That makes that positive. That makes that negative. Very good. So there you go, ladies and gentlemen. That is how you evaluate the sum and difference formula using, or the sum and difference formula for tangent. Thanks.